Welcome back to another week of Forecast Lab. We've got the cumulus flowing north with tropical air coming up from the Gulf, and as you can see, these clouds are sheared. They've got a little bit of tilt to them, like you can see them leaning from right to left. And this is looking to the southeast, and that's showing that we've got shear kind of working in a north and northeastward direction. So this is the moisture coming up, and up above that, very important, you can see some blue sky. So there is some dry air in the mid and upper levels, and that's going to be important for today's severe weather. Looking at that surface chart in the southwestern U.S., we've got a cold front coming down out of the central plains. And behind that, some continental polar air. And I'll put that K on the end because it is modifying, becoming warm from the bottom upward. In the Four Corners area, we've also got a bit of a Pacific front moving southward, and it is heavily modified. You can see the 90-degree readings there at Kingman and Las Vegas. But the true continental tropical air, that's over southern Arizona, where we've got 91 degrees at both Phoenix and Tucson. And as you move eastward, you can see the downslope air, the dry line present out there in the San Angelo-Abilene area. And behind that dry line, we've got 95 degrees at Midland and those dew points in the 20s and 30s. We are expecting storms to develop along that cold front, and that'll move through much of Oklahoma southward and into North Texas, mostly along and east of Interstate 35. There's the convective setup, looking at the visible satellite imagery, so we're at the very beginning of the convective day. And we can see the front running about like that. We've got thunderstorms back behind the front, which is helping to reinforce that front. Out ahead of it, it looks like we've got maybe a little bit of a worked over air mass here, possibly some previous thunderstorm activity, and then we go south of there and we get into the pure tropical air. We can see the cloud streets leading north. And as we go further west, we get into the shallower moisture. A lot of it's mixed out, and you go further west and you get into very dry air. And that gets into the area behind the cold front or behind the dry line. Putting the station plots on there, we can get some idea where the front is. So it looks to be in that region right there, and we can see the transition between the tropical air in the Oklahoma City, Yukon area and the post-dry line air. So it looks like the actual dry line triple point is going to start around Watonga, Oklahoma, and extend south to about, looks like maybe the Vernon area, and then down to about Graham. So that right there, that's the triple point area. Anywhere northeast of there is going to be kind of a ripe location for storm development. And south of there, in this region here, depends how good the convergence and the moisture is. And we also do need to run things back and see how things were last night. You can see there was an MCS there in northeast Oklahoma that moved into Arkansas. And then the high-resolution rapid refresh model was correct, breaking out that area of precip northwest of Fort Worth. And that moved southeast. By dawn, a lot of the convection was across eastern Oklahoma. And then we see the new forced convection developing in north central Kansas. That's just in the past few hours there. And that's where we're at right now. I did have a little bit of a question how far north or south the cold front is. It is possible to put it along that cloud axis right there, but we've got a couple plots that suggest the cold front is out further south. So what do we do in this area? Where do we get data from? We can go to the Oklahoma Mesonet. So if you put Oklahoma Mesonet in the search engine, you'll be able to pull up some of these plots, and let's see, it's definitely a lot more evident. You can see a wind shift right in there. It's a little less certain further up north. And then going down the boundary, see this 92-degree reading around Elk City and up in that area. That's going to be probably where the cold front has just arrived. Yeah, kind of like that. So we can actually take that and transpose that to the satellite. So that's what I'm going to do. And before I do that, let me outline the dry line. I think that's going to be my final location right about like that. So I can just basically nail that right down to the county where all these boundaries are. And that is very important for doing a proper mesoscale analysis. So that right there is the analysis, triple point near Clinton, Oklahoma, and the boundary extending northeast, just north of Enid, Oklahoma. And we know that the radar, the Enid radar, is right in this area, so we may be able to see that on the next rad imagery. And how about that? I just took a guess, and yeah, it did show up. There it is. There's our boundary. So we can take that and apply that to our surface analysis. So that boundary is basically going to be right there. If we were expecting the cap to break, I would be looking for initiation right in that area. And we can also see that boundary on the velocity imagery. This is base velocity. Red is flow away from the radar being right there. So this is showing the north to south movement of the air mass. And then south of that boundary, you get into the green. That's a component of flow toward the radar. And I think maybe even the spectrum width would show up. Yep. There it is. So there's all these tools. There's all these tools you can use. Just fantastic. Use all that and you can get right down to a very granular level where all the boundaries are. What's interesting is you can also see some of the wind farms. They'll show up very nicely. And there's a quick look at the Oklahoma Mesonet site. And if we want to look at severe weather risk, well, I'm more interested in probably the moisture. So I'm going to go to this dew point and humidity and select dew point temperature. So we can take this and find our moisture axis. It's going to be running about like that. So with downbursts being the main threat, this would probably be one of the higher risk areas for today. Anywhere from just west of Tulsa, south toward Durant. Well, we can't forget the southeast U.S. Pretty quiet for today, but MCS out there in Louisiana down to southeast Texas. And on the backside, we can see the outflow boundary. See that right there? And if we run that back, you can see the MCS activity in East Texas kicking out that outflow. See how it goes up, and then the outflow kind of spreads west and north. So those can be important boundaries later on. Anyway, not much going on in the southeast U.S. and then on the surface map, also pretty quiet. The main feature is this almost a primordial Bermuda high sitting there on the southeast coast. And then on the west side of that, we've got the Gulf open, and the highest moisture appears to be coming onshore around Houston, moving up I-45 towards Dallas. And for the northeast U.S., let me guess, cold northerly flow? Well, not really. It is cold. Air mass is kind of stagnating, and it's starting to respond to the southerly gradient coming out of the Midwest. Got this baroclinic system in Iowa moving east towards the Chicago area, and further north we've got an occlusion in North Dakota. And we know that that's an occlusion because it's cut off from the warmer air. If we look around on the chart and find the warm sector, that's in Indiana right there. That's going to be east of Champaign. I guess I don't know all the cities there, but that's going to be around the Indianapolis area, almost 80 degrees, and some of that extends up towards Springfield, the Quad City 74. So that's the moist sector, or the warm sector right there. So this is going to be detached from all that warm air. And that places the main baroclinic zone right in here. And then the upper level jet, we would expect to find that kind of running somewhere just north of that boundary. And there's a quick look at how things look on the satellite. That southerly flow coming up through Ohio there. You can see once that flow hits the cool Lake Erie surface, the convection just kind of dies out. So it's kind of the opposite of lake effect convection. And then it emerges on the north side of the lake around London, Ontario, and gradually starts picking up some convection on the north side of that peninsula. Also, the surface system shows up on the satellite. We can certainly see the cold front in eastern Iowa like that. And then the warm front doesn't show up quite as well, but that little concentrated area of cumulus, broken overcast conditions, that's going to be just north of that boundary. And then we can follow the occlusion north up into western Wisconsin right there. And there's our map for the Pacific Northwest. Very cold, blustery air coming down out of Montana. Not quite as cold as a couple weeks ago, but still 50s, enough to give us a little bit of a wind chill there. And the highest gust that I'm seeing, 43 in eastern Montana there. This is in knots, so that's going to be close to 50 miles an hour. Large, cool air mass across Washington and Idaho. And then on the north side of that, where we have the westerly gradient, looks like a lee side trough in Alberta. So we're gradually changing over to spring weather. I'm not sure if we have any viewers in the Pacific Northwest, but it is pretty clear. Out in the plains, you can see that cold northerly flow right there. Cold air in the mid-levels with strong warming from the surface on up. And then on the other side, out there in Washington, looks like a cool Pacific air mass working its way inland. And there's our quick 15-second look at Europe. Looks like a pretty active Atlantic system moving through Germany into Italy there. And I understand that produced a little bit of severe weather across France and Germany. I don't have the details on that. We're pretty... And there it is. We know that the front is well out to the east. And out behind that cold front, we can see a lot of showery weather. Got a lot of cold air in the mid-levels. That, with a very strong heating, gives us a similar pattern to what we have in the northern plains. Cold, showery weather with a strongly diurnal characteristic. So, for this evening, there's our SPC forecast. Moderate risk for all of eastern Oklahoma and a huge chunk of northeast Texas. Do we have mesoscale discussions out? Yeah, we do. This is covering the initial part of that area east of the low and ahead of the cold front. I don't see much about the dry air aloft, but it is in place there, and that's given us downdraft capes of up to about 1,300. Do we have a watch out? Yep, watches are in effect. Looks like the eastern half of that watch is a tornado watch. The other is a severe watch. So it is starting to come together. So at the time we're recording this, this is how the cells look. They have a multicellular appearance. I'm checking the products out for boundaries. Don't really see one on spectrum width. Yeah, base velocity seems to show that boundary right there around Winfield, Kansas. So that's probably going to be the start of that cold pool surge southward. And the evolution of that MCS is to expand along that cold front, some back building down towards the Oklahoma City area. And then by 0Z, 7 p.m., we got kind of this broken line, and you can see that in parts of the line there's kind of a bow echo appearance, like right there. If you go to other frames, you can find other areas of bowing. Looks like that's the main one right there. And here it's showing a meso-high. So I'll put that H there. This is going to be 9 p.m. Anywhere around that meso-high, anywhere up and down that line, those are potential areas for bow echo development. And you can see there's one right there. Of course, we don't want to split hairs on that. That's probably not actually what's going to happen. But it shows you the potential and the areas where there's that possibility. You can see there's one there around Durant and around the Lake Texoma area, 11 p.m. still showing bowing characteristics right there. And this continues on through the evening. By 6E, 1 a.m., coming down into the Tyler area, it is still bowing. That continues. And I know that with earlier runs, we were looking at this area to dissipate by about 5 or 6 a.m., but the latest runs seem to continue pushing these bow echo elements all the way down towards the Gulf. See that right there? So it's probably, yeah, and there probably is an analogy for this. May 4th of 1989, there was a derecho that moved all the way from Amarillo down to the Gulf by dawn. This seems to be kind of a similar situation. I don't know if it's quite as severe, though. But, yeah, do a search for that. Yeah, there's that derecho, and even though this is probably not remotely like what we'll see tonight, it can give you a little bit of context that might help your forecasting efforts. So if things go downhill, you'll have an idea what to look for. So one thing we can do to assess the risk is to look at the air mass ahead of that MCS. Let's bring up a forecast sounding 9 p.m. around Paris, Texas. This is a high-resolution rapid refresh forecast sounding. And it does show some dry air aloft. There it is right there. It shows that there's some marginal shear for tornadoes. Well, I would call that probably decent shear. Although if things are going to be very linear, it's going to be hard to sustain tornado activity since it will be undercut. But if you look down here, downdraft Cape 1100, so that's getting up towards the range where we're looking for strongly outflow cells. Let's bring that further south towards let's try the Tyler area around 1 a.m. And we've got, yeah, downdraft Capes about 1100 to 1200. And another very useful value is the Corfiti downshear value. See that right down here? That Corfiti downshear value gives you an estimate of a forward propagating squall line, the movement. And you can see that it's going for as high as 51 knots out of the northwest. And we can just pull some values around like Shreveport, 305 at 40. Again, these are just forecast values. Wow, 340 at 59. So it's certainly suggesting a fast-moving squall line. All right, we need to start looking at getting this presentation out the door. So just a quick look at the forecast for 7 p.m. There's our cold front. Pretty much like what we saw in the surface analysis. There's our MCS kind of heading south. And then we can see by 3 a.m., definite bowing shape heading south towards Houston. So it appears that squall line is still active. And then by 6 a.m., 7 a.m., it's already off the Gulf Coast waters. And we can see that very strong cold air coming in the Central Plains. Then by tomorrow night, looks like kind of a forced MCS in the Appalachians down to Atlanta. If you're flying through Atlanta Airport, probably going to see some delays there. Warm front moving up towards, looks like Pennsylvania and New Jersey, and then the occlusion going out towards the Great Lakes like that. You can see that little blob there of cold air moving across the Midwest. So high pressure in Texas, and that means that the return flow coming up the Rio Grande is not quite set up just yet, but it should start getting into motion there by Thursday night, maybe even Friday. So there's our map for Thursday night. Looks like we're just starting to get the return flow coming up in the high plains. You can see that high there moving out into the Gulf. And that's probably about the last frame I have. So after that, we need to go to the GFS, and we'll just take a quick look at that GFS and see what it's got in store. Friday night, the Gulf is starting to open up just a little bit there, but it's still pretty dry. You can see the lee side trough there active with 995 millibar low there. Looks like another little bit of cold air coming south out of the Great Basin region. Then by Saturday night, looks like an active frontal system up there in the Central Plains. Frontalysis there in Arizona and New Mexico. And this looks like upslope activity there in Colorado. So I guess some of that moisture is working its way up to the north. And then for Sunday night, looks like another cold front sneaking into the southern plains there. And things really come together there on the west coast. Very active system going through Nevada. And then just kind of quick look at that. Yeah, big wedge of cold air coming in from the west. And that really gets things going out on the plains due to that troughing out west. This is for Monday. And then for Tuesday, looks like another little boundary coming down into Texas. So a little bit more severe weather. And then things will be kind of shut down for a while. Most of the activity will be in the Big Bend area, maybe the Rio Grande region. It's almost like a late March, early April type pattern there. And then another Alberta Clipper coming south. The winter just never ends. There it is. More cold air on its way south. May 9th. That would be weird if this was like the year without a summer. I'm sure that's not going to happen, but anyway, it's fun to think about. All right. I think I'll get this wrapped up and posted. All right, guys, that's probably about all I've got for tonight. I need to get this edited and uploaded before it gets too late. We are expecting a round of severe weather in this part of Texas, and with this being late April and May, things can get kind of crazy, so we're probably expecting some severe weather. Hopefully we'll have a studio to come back to tomorrow, but I'm sure we'll be okay. But I'll try to get some footage if we see anything interesting outside. And thank you to our newest supporters, Jeremy Dawson and Robert Bellaspirito. I appreciate your support. So we will see you all again tomorrow. Have a good evening and take care. Bye-bye.